Good day, my dear friends. The question on the board has to do with a car moving with a velocity of 50 meters per second, accelerate uniformly at the rate of 2 meters per second squared to reach a velocity of 20 meters per second. Calculate the time taken and then the distance traveled. All right, this is a simple question indeed. We are going to approach it wisely by, first of all, fishing out the data that the question contains. That's the first thing we need to do. We need to find out, we need to bring out the data or the information that the question contains. So, we do that right away. Data that the question contains is very simple. We have an initial velocity, that is 15 meters per second. That's the initial velocity. U is equal to 15 meters per second. And then another one is the final velocity, okay? The final velocity here is 20 meters per second. So that is represented by letter V, 20 meters per second. All right, but the car accelerates. It accelerates uniformly at the rate of 2 meters per second squared. Okay? Look at it. Accelerates uniformly at the rate of 2 meters per second squared. So we take note of that as the acceleration of the car. So acceleration here is A is equal to 2 meters per second squared. Okay? 2 meters per second squared. All right. We are expected to find two quantities here, the time taken t and the distance traveled, okay? The distance traveled is represented by the letter x, all right? Okay, so that is what we need to find. The first one is time taken is unknown, right? Okay? The second one is the distance traveled is unknown, okay? All right. So, having stated this, the next thing we need to ask ourselves is which of the equations of motion is most appropriate for solving this kind of question or problem. All right. Our conclusion is that we can apply a change in velocity, okay, over time. Since this relation has something to do with time, okay? And the time happens to be the first quantity that we are looking for, according to the data contained in the question, right? So we can transpose for t here. We transpose t to be the subject, okay? So t is equal to change in velocity all over the acceleration a, all right? From relation 1, we got this, okay? The next thing we need to do quickly is to substitute. We substitute for final velocity, which is 20 meters per second. We substitute for initial velocity, which is 50 meters per second. And then finally for the acceleration of the car, which happens to be 2 meters per second squared. So we do that without wasting time. 20 minus 15 all over 2. Okay. All right, so if we continue like that, 20 minus 15 will give 5 over 2. So our final resolution here is 2.5 seconds. Okay? 2.5 seconds. That is our final answer here. So t has been obtained. The value for t is 2.5 seconds. Okay, we have found t. The next we need to find is the distance traveled. The distance traveled by the car. As it accelerates uniformly, it reaches certain amount of distance, which is unknown in terms of value. So that's what we're going to find next. All right, and for us to do that, we apply another equation of motion, which is of very much importance to us. That is ut is plus half AT squared, okay? That's the question that will help us. This time around we need to clear certain things, okay? We need to remove this, all right? Because it's no longer needed, okay? Now, we have something very, very beautiful on the board that will help us to find the second quantity that we are looking for, the distance traveled. That's what we are looking for, all right? And that's all. If we now consider the fact that the initial velocity has been given as 15, all right? Time has been found to be 2.5, okay? Plus, all right? And we move on again, we have 1 all over 2, okay? According to the formula, right? Yeah. Okay, the next thing is the acceleration is giving us 2 meters per second squared. That is this. We substitute. This should be taking this, okay? The next thing we need to consider is it's like I'm squeezing this thing at this point. So let's just try and do something here. Let's just take something better than this. We have 1 all over 2, that's this, okay? Right? And then the acceleration is given as 2 meters per second squared. And then remember, we've already found the time as 2.5. 2.5 at this time is going to be squared because it is squared at this point. All right, so what do we do here? What do we do? It's very simple. So this one, 15 times this will give us 37.5. Okay? And 37.5, you can add 0 if you like. Here, we first of all evaluate this. 2.5 squared. 2.5 squared, we give 6.25. And then 6.25 times this will give about 12 point something. Okay? So at the end, by the time we divide, we still have 6.25 as what will remain. Okay? Then we add. If we add this wisely, we will arrive at 43.75 meters. Okay? By the time we add 37.50 plus 6.25, we will get 43.75 meters. That is the distance traveled in this very particular time. That's the distance traveled. Okay, so it has been found, so we can conclude by saying, therefore, x, the distance traveled is 43.75 meters. Solved. All right, so it has been resolved in that way that with this formula, as you see, you can solve so many questions